Ayyıldız from Bilkent Electrical and Electronics Engineering, and for my EEE 102 course term project I have done this optical based communication system, and it's capable of sending text images, text files as well as image files. And here let me explain it a bit further. Before proceeding with the software design I have done, I'd like to show the hardware part. Actually, I have one breadboard, but there are two separate systems that I have running in this design. Initially, I wanted to have two separate systems, one for sending part and for the receiving parts of the communication system, but due to budget reasons, I utilized my one and only FPGA board, Basis 3, which is connected to one host PC for this instance via a USB-T UART bridge, as you can see here. And I'd like to show the exact parts of my system. The LED you see in this part that is looking blue is actually my infrared LED system, which is always on but pulsates my data bytes according to the stimulations coming from the FPGA board, which is initially connected to the PC. Then my photodiode here that you can see with the black cap actually recovers these pulsations, flickerings, and sends them back to the FPGA board, which actually puts every received data through a receiving procedure. So I have one board, but I have two procedures running at the same time. After I showed you the hardware, let me show the software as well. I have one sender code in here that you can see and a receiver code in here, and I run them simultaneously on a top folder and on a top VHDL code and send this top VHDL code to the FPGA for the programming part. As I mentioned, this is all due to using one board, but actually my design is capable of running on two FPGA boards as well, which I have to tweak just a little bit to make it work. But it's initially designed for two boards at the same time, but with one top folder that I'm using in here, I can run it in one FPGA board I have right here. And other than that, I actually partition and send my files from PC to FPGA board for the procedures. I use a Python code for that. The same Python script actually recovers received input from the FPGA board and reconstructs the file once again. Let me show you how it actually works. In here, I have a Python code that I use to send files, and it is also capable of receiving and reconstructing as well. And here, let me show you how it works. When I press the start button and run the code, it first asks me whether I should run it on normal speed or the high speed. On my FPGA board, this switch 0 that you can see here, actually I should choose which mode I will be running the system on here as well. When it's on like this, it means that the system will run on high speed mode. When it is flicked to off, it will be running on the slow pace mode. To be able to show you the system in a much more secure sense, I actually made the fast pace and the slow pace a bit more close to each other, but we will be able to see them in here as well. For the first test, I'll be running the system on normal speed, so I'll be switching my FPGA board to initially 0 on switch 0. And it asks me to enter a valid sender ID, and it has to be an integer, that's why it says valid. And it will be showed on this FPGA board. What's another feature that I put on this board is when I flick this switch 1 to on, the board will be showing when the process is running. If there are any errors occurring on the system, every time it occurs and it gets fixed by my internal protection system on the communication line, it will be incremented by 1. And here let me, for testing purposes, enter 1 as my sender ID. For the initial test, I actually have these images file which I'll be sending my images if I want to test images, and I have this test text that I will be sending if I send the text. On received images, I have a image from previous test that I have done, and the received text is actually just empty. It just says hello world from the previous testings. I'll first be sending my image on slow mode, and let's say it is the test.png that I have in my image files. While it is sending, let me show you the initial test PNG. It is this image that is a bit high resolution, which will, after the process is done, will show up on the received image part. And while that is happening, let me show you the sender ID that I have. It is 1 as we have entered. And now, in a few seconds, we'll be seeing the ending result that we'll have. And here it is. I have done no editing, of course, and the image that we have got is just a bit more pixelated than the original image, but it is what we receive. And for testing purposes, let me rerun the code in high speed, and that's why I'll be flicking my switch to high speed mode. And this time let's enter a valid sender ID of 3, and my image will be another image from the testing parts that I've got here. Let's let it be gem.yilmaz.png. The previous one, the slow mode one, was actually, if I don't know if I showed it, but it ran in 27.40 or similar to that time, and it should run in a faster pace, and it will be less time spent on sending part on if we see on the sending part. And here you can see it's 24 seconds on here, and the received images like this, which is a bit more pixelated than the original image that we've got here. I forgot to show it in the previous segment of the video, but on my FPGA procedure, I have got actually protecting layers done by algorithmic mathematical equations, and I have utilized Hamming 7.4 protection system, which heals single bit errors for my serial data lines, and I have it running as well. And on my FPGA code, there is a counter that I increase every time my FPGA does a single bit error fixing. And let me show you the testing part. And for testing, let's run test.png here. Here, if I disrupt the process with anything outside, like this part, I flick this error panel on. If I flick it, yeah, the error part increases by a lot, and it shows me that there's an error on the system. I understand that everything is going not as expected and anticipated, and the received image will be distorted as well, which we'll be seeing in a few seconds. This is the wrong image, as you can see in here. For my last test, I will be running a txt file in, let's find it in high speed as well, and let the sender code be, I don't know, 8, and let's run our text. Since I have just one text, I don't want to enter a name. If you can recall, my receipt txt is empty, and on my sending txt, my test.txt, I have got a poem by Edgar Allan Poe here, and let's see if the process is done. Yeah, it is done in 10 seconds on high speed, and the received text is here as well, which has got no problems. So this is my communication system that I have got, and thanks for listening, and remember to leave a like